Good morning, everyone. Welcome to our module presentation. Our module is called Getting Started with Unit Testing Cases. Our target learners are students with less programming background. Our module will be inserted into an introductory programming course after 1 week of programming has been taught. There are three common learning challenges for students who just started their programming journey. They are easy to create bugs, don't know what to do when getting errors, and cannot think from a bigger wheel. So they will ignore cases which are not explicitly told to handle. Of course, there are some common principles and guidelines in programming to avoid bugs and common errors, but it will be overwhelming for students to learn these principles just using a new programming language like C or C++. So we think that using Scratch, which is more acceptable among beginners, we can teach students these principles in an easier way. We started from the point that we will teach students how to debug, but later realized that it is too broad of a goal. So based on our empirical and theoretical CTA, we finally changed our focus to test-driven development and narrow it down to unit testing. We hypothesize that by learning how to write unit testing cases, students will increase their program writing abilities and learn how to fix bugs by using failed test cases.
These are our four goals. We built our goals based on Bloom's taxonomy and ABCD method. Guided by the big picture of backward design process, we built our instructions and assessment activities based on the goals. As you can see in the alignment form, each goal is targeted by three formative assessments and has some instructional actions related to it. Then, it comes to our CTA part. We came up with this theoretical model based on how debugging is done. But during the Think Loud, we noticed two things. Most novices don't have any strategies for fixing an error. They just try and guess what might be wrong before giving up. Experts are more familiar with using unit test cases to find and fix bugs, even though they didn't use that word, but when they were probed to think aloud, explicitly what they said in most cases will support unit testing strategy. Second, we identify the problems in our model. If the program is not working as intended, instead of thinking explicitly about how to debug, experts intuitively guess and pick an input and output pair which are failing. They will make the program work for it. However, novices have to do a lot of think aloud when asked which input-output case fails explicitly before they could write in a paper what happened. Based on CTA results, we narrowed down the focus from debugging to test-driven development, which is a good strategy for finding and locating errors. For novice, writing unit test cases could act as a kind of like a scaffold for debugging, and there is less chance of errors in the code. We also added a goal to recall the big picture, which we came up with after doing theoretical and empirical CTA. The CTA with novice inspired us to revise the model. We asked participants to fix a bug by use unit testing. As you can see from the transcript, the novice participant only focused on the positive value in each section, and then get some medium value and finished building unit test cases. Yes, the novice participant overlooked all the negative inputs and the boundary inputs. They were able to use these cases to conclude all of them pass, but couldn't do the second step properly, so we decided to focus mostly on that. In iteration part, we revised our model based on feedback of learners' testing. Several insightful points from slides and quizzes are shared with you. First, we found that students easily lose motivation when they found that there are 30 pages slides in one part. So we divided into 3 parts and moved some parts into a video instead of the text and image version. We got positive feedback. Second, novice had difficulty to follow the electricity problem in the side. Even we wrote lots of explanation, they still feel very difficult. So we record a video to explain it, which also got positive feedback. Third, for the quiz observation, students felt no knowledge for terminologies like non-value validation and illegal data tap. So we added explicit reference in the instruction to point out what is non-value validation and illegal data tap to explain the terminology for them. The result is the correct rate of the targeted assessment question in post-test is more than 80%. The most interesting thing we observed is, in the beginning of pre-quiz, all of users feel confused about the big picture. But all experts did it correctly based on their intuition. Novice just did it randomly. And when experts saw the big picture, they agreed saying that they have the similar picture of TDD in their mind. And at the beginning, the words in our big picture were not that explicit. So we revised the words in the big picture based on the feedback, and we got positive feedback from students. Well, not every change works smoothly. This is an unworked revisement. We observed that students had difficulty understanding path coverage and also the related questions in the quiz. So we decided to add flowcharts explanation with labels in each page and used an easier example. However, the results show that the relative question is still the most tricky one in both the pre and post-test. Although students made huge improvement from pre-test to post-test, the average correct rate is still less than 40%. Why it is not work? We came up with 3 possible reasons. And after we divided our learners based on the average rate, we realized that even half of students in high score group got that question wrong. Maybe the reason is that it is not a good targeted question. Now, it comes to our innovative principle. We give them feedback on formative assessment, so they learn by doing. In the slides, we have some interactive worked example with feedback to address any errors they can make while solving that problem. We hypothesis not only feedback will help them in learning, but the interactive slides we made that give feedback on what option you select will keep learners engaged. For A/B testing part, as you can see, we did A/B testing on total 31 learners, 20 for treatment group and 11 for control group. We initially divided 20 students into 2 groups randomly and let them follow the course schedule to do pre-test, instruction, and then post-test. But then yesterday, we discovered that, to our surprise, that in instructor view, our A and B version were different, but for student view, all of them only got the treatment version due to an unknown deployment error. So we redeployed our control group version and recruit 11 learners for it. Learners in treatment group gained more in average compared with the control group. The result showed us that more instant, interactive, and detailed feedback will help to learn more. The feedback principle appears to work in our module now. Here is an interesting finding from our treatment group. The average learning gain of different prior knowledge group shows that lower pre-test students show bigger gains. Of course, these students have more room for gain, and this phenomenon might be caused by regression to the mean. But we still think it means that our module is a useful entry-level course. We also found that there is estimated learning level in OLI system. Based on the given dot plots, we find that students' progress of goal 4 is undesirable. Maybe it is because we only have one question for this goal, which non-native speaker reported that options was a little hard to understand, so they got confused. All in all, we got very positive feedback, especially from learners with little programming experience. They said that they benefit a lot from the module. For the future plan, currently, there was only one question for Goal 3 and 4, so we couldn't measure properly whether learners achieved these two goals. We are planning to work on that and try to see how to adjust the whole structure. Also, we have some plans based on learners' suggestions that we want to try out. Thanks for listening. Any questions now?